Good morning, students. In the previous video, we studied about the half cell and the electrode potential and the standard electrode potential of the half cell. Now the question arises that when we use only one half cell, its electrode potential cannot be determined. So to find out the standard electrode potential of any half cell, for example copper half cell, of zinc half cell, etc., we have to use some reference electrode. Means we have to find out the standard electrode potential of any half cell in reference to some another half cell or a particular half cell whose standard electrode potential is known to us. So here we are going to study about this XII, that is standard hydrogen electrode. You can see this is made up of a glass tube, and here this is the platinum coated foil, and it is the connecting wire, and this is dipped in the solution, 1 molar solution of the HCl, and the H2 at 1 bar is bubbled in this. Okay, so by default its standard electrode potential is assumed as 0. Okay, now to find the standard electrode potential of any half cell, this standard hydrogen electrode is put in the left side. In left side it works as anode, and the half cell whose standard electrode potential is to find out is put in the right hand side, and in right hand side that half cell will work as cathode. Okay, or you can say here E0 cell standard electrode potential of that cell is equal to E0R. E0R means the half cell in right hand side minus E0L. Here we are just to know, we are going to find out the standard electrode potential of the copper. So in right hand side we have put the copper half cell, so E0 Cu2 plus 2 Cus minus 0, because in left hand side we have put the standard hydrogen electrode, that is reference electrode, and by default its standard electrode potential is 0. So whatever the potential or whatever the EMF of that cell is noted on the voltmeter, that is the value of the standard electrode potential of the half cell. That here we have used the copper, so it will give the value of the standard electrode potential of the copper half cell. Now one thing is to be kept in mind, that when we are going to find out the standard electrode potential of any half cell, we have to take the concentration unity. Means here if we are taking the copper sulfate or copper nitrate, etc., its concentration must be 1m whenever we are going to find out the value of the half cell. And this is the cell notation, you very well know. Cell notation in left hand, this shows the left hand side and this shows the right hand side. Okay, these two half cells are bifurcated from each other by two long parallel lines, and here suppose in right hand side, here this is the oxidized state, then this is reduced state, and these are separated by the single vertical line. And same thing is here. In left hand side the oxidation takes place, so the reduced to oxidized state, and in right hand side that is the cathode, where the reduction takes place, so oxidized state to reduced state. Here reduced state, then a vertical line, then oxidized state. Okay, so this portion denotes the half cell in left hand side, this portion denotes the half cell in right hand side. In half cell the oxidation is taking place. Okay, in right hand side the reduction will take place. Okay, now if we want to find out the value of the EMF of any half cell, okay, to find the EMF of any half cell we have to use the Nernst equation. Nernst is the name of the scientist. This is like this: E mn plus oblique ms equal to E0 minus RT upon Nf. Ln ms molar concentration of the metal in solid state divided by the molar concentration of metal in aqueous state. Okay, and we very well know the concentration of the solid state is it can be taken as unity. So this formula becomes like this. Okay, thank you. In the next video we will study about the working of the Daniell cell, which is the basic of the electrochemistry, and we will find out the value of the EMF of the Daniell cell. Okay, thank you.